All right, so we're into chapter 4 now. And chapter 4 is all about rational functions. And honestly, we're going to do 4.1 and 4.2 together, just basically because one flows right into the other and there's not really any need to take the break there. But we'll probably have to do this lesson as normal in maybe 2 parts. So let's start by defining a rational function and then we'll see what we're going to do with them here. Okay, so let r of x be a rational function. Then r of x is equal to p of x over q of x, where p and q are polynomials. So a rational function is going to be a function that has fractions in it, and basically it's going to be a function that's a polynomial divided by another polynomial. So we might see something like r of x equals 2x minus 3 over x squared minus 4, let's say. Okay? So a small polynomial up top, a little bit larger one on the bottom, but that's what we're talking about. Some can be big and ugly, some are more like this. So what we are going to focus on then is we are going to focus on graphing these guys. And through graphing them, we're going to learn some more about them. So first what I want to do is I want to break this down into something a little easier. So we're going to go back to the basics and we're going to let y equal 1 over x. Now when we had y equal to 1 over x, this was one of our base functions, and this was kind of the weirdo one. This is the one that looked like 2 parts, with the y, it looked like 2 parts, and this one kind of hugged down here, and this one kind of hugged up here. Okay, so 2 parts like that. And truth be told, these 2 parts stay in their quadrants where they are. And so what ends up happening is there is like this boundary line that's running vertically down through the y-axis, and then another one that's running horizontally through the x-axis. And those boundary lines are called asymptotes. And asymptotes are found on rational functions. So let's define an asymptote. So an asymptote, which is just about the weirdest word there is, asymptote, is a line that the graph approaches but does not cross. So this arrow is getting closer and closer and closer to the x-axis, but the asymptote means that it's never actually going to reach that. Same thing with the y-axis. It's getting closer and closer and closer, but it never actually reaches that axis. So it's just hugging in there. So these are like boundaries that are, or fences you could say, that kind of keep your graphs contained. So when it comes to our base function, the asymptotes are nice because they're on the x-axis and the y-axis. And notice that we have both a vertical one and a horizontal one. So there's a vertical asymptote, and a horizontal asymptote. And as I said, all rational functions are going to have these asymptotes. The base one does, this guy does, rational functions have asymptotes. So when it comes to learning about a rational function, whether you're graphing or not, one thing that is important is understanding the asymptotes. So that's what we're going to start with here, is we're going to start by looking at these asymptotes. So let's start with the easier of the two, and the easier of the two is the vertical asymptote. Let's go with the vertical asymptote. Vertical asymptote. So the vertical asymptote, seems weird to just write it again. Is found by setting the denominator equal to 0. Oops, not dry enough there to write on yet. Equal to 0 and solving. So truth be told is the vertical asymptote is going to come from our domain. Okay, so from our domain, that's where we're going to see that vertical asymptote pop up. So let me put that rational function up again that we just had here. So it was 2x minus 3 over x squared minus 4. So if we want to find our vertical asymptote, which we're just going to abbreviate VA for vertical asymptote, we're going to take this guy and set him equal to 0. Now think about that. That's the values that are not going to work in the domain. So right off the bat, we're back to domain issues going on. So if we move over the 4, we'll have x squared equals 4. So x is going to equal plus or minus 2, right? Don't forget that plus or minus sign. So this one actually has 2 vertical asymptotes. Our base graph only had one right there. This graph is going to have 2, one at -2 and another one at +2. So something for us to note. So finding the vertical asymptote is normally the easiest part to find. Denominator equal to 0, solve. It's the horizontal that's a bit more challenging. So let's look at the horizontal, and then we will look at some of these examples here. Okay. Let's erase this. And then we'll get right into graphing. We just have to get these asymptotes taken care of, and then it's on to graphing. Okay, so horizontal asymptotes. Okay. This is going to start and it looks a little bit ugly. Once you get the habit and hang of it, it's really not that bad. So we're going to say first, we're going to let r of x equal a sub n x sub n plus a sub n minus 1 x sub n minus 1 plus a sub n minus 2 x sub n minus 2 dot dot dot. So we're letting it equal that basic polynomial format. Here's the leading coefficient, here's the degree, and then it slides down. But we're going to make it, because it's a fraction, we're going to have another one on the bottom. This one is going to be b sub m x to the m plus b sub m minus 1 x to the m minus 1 plus blah, 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 blah. Okay, so we have two polynomials being divided by each other. Now, when it comes to looking at the horizontal asymptote, the only part that we're interested is not the blah, blah, blah. We're looking at this part of the fraction. So we're looking at just this part. That's the important part. So, couple situations here. So we say if n is less than m. So if the top one is less than the bottom one, that's the situation we have here. The degree on top is 1, the degree on bottom is 2. So we're in this situation. Then the horizontal asymptote y equals 0. And this is the x-axis. Okay. So if the degree on top is lower than the degree on bottom, then the asymptote is right there at 0. Nice, no issues. Now, if the 2 degrees are equal, so if n equals m, so not our situation, but if n equals m, same, then the horizontal asymptote, which I'm already tired of writing, so I'll write horizontal asymptote like that, is y equals a sub n over b sub m. Okay, so remember what I said. These guys right here don't matter. Okay, none of this matters. It's all right here. If these 2 degrees are equal to each other, then the asymptote is actually going to focus on the leading coefficient. And it's just the leading coefficients divided by each other. So we'll see an example of that. Okay. And then finally, the last one says, if n is greater than m, so if the top one is bigger than the bottom one, so kind of like an improper fraction, so if n is greater than m, there is no horizontal asymptote. But an oblique asymptote. Now, the oblique asymptote for right this second, for the beginning of our lecture, we don't want to worry about. We're going to deal with these 2 situations. Then as we get to the second part of our lecture, so probably in part 2, that's when we'll see this one. But if the degree on the top is bigger than the degree on the bottom, then there's no horizontal asymptote, and then something weird happens, and we'll have to take care of that when we get to it. Okay, and we will. Okay, so vertical asymptote, denominator equal to 0, horizontal asymptote, a little bit different. So if we were being asked here, and then someone said, can you find the horizontal asymptote, we would say smaller than on top than on bottom. So this is y equals 0. If, let's say, though, it happened to be r of x equals 4x to the 5th minus 7 over 8x to the 5th plus 2. And I'm only interested in the horizontal asymptote for the moment, okay? So if I'm asking for the horizontal asymptote, we go, oh, same degree on top and bottom, so bring yourselves out in front, and we're going to create y equals 4 over 8, or y equals 1/2. Okie dokie. So unfortunately, I have to erase this so we can draw our graph, but get it written down, push pause, get it written down, and then let's erase and do some graphs. So these graphs that we're gonna make, we're not gonna make them itty bitty like this. This is gonna be a good size graph because there's gonna be a lot of weird things going on it, okay? Now, I'm starting you off nice, and then we're gonna make them uglier. So this first one might look a little simple, but that's okay, right? So this one is r of x equals x minus 3 over x minus 1. And this is going to say graph using asymptotes and intercepts. Asymptotes and intercepts. Okay. So vertical asymptote first, like I said, that's normally the easier of the 2 to find. Okay, vertical asymptote, we take the denominator and set it equal to 0. So x is going to equal 1. Now, right off the bat, right over here, we can get going with our nice size graph. Very nice size graph going on there. And we're going to put our vertical asymptote at 1. So there's 1. And we're going to do that by drawing a dashed line. And we're going to label it VA. So you should have it dashed in and you should have it labeled. Okay? Then we move on to the horizontal. Now again, it would have been nice if we still had that written there, but you have it in your notes. So we look at the 2 degrees. They're the same. They're 1. So that means we look at the numbers before, and even though there's no numbers, it's like there's a 1 over a 1, right? So we're going to say y is equal to 1 over 1, the leading coefficients, which is also 1. So on the y-axis, our horizontal asymptote is also at 1, and we're going to dash it in there, and we'll label it horizontal asymptote. Okay, so asymptotes on the graph first. Now we're going to go to our intercepts. So y-intercept is always the easier of the two because we're just plugging in 0. So if we want r of 0, 0 minus 3 over 0 minus 1 is going to give us positive 3. Right? Positive 3. Okay, so that's our y. So we're going to go up to 3. And now we need our x-intercepts. So to find our x-intercepts, we're going to set that guy equal to 0, aren't we? So we're going to take x minus 3 over x minus 1 and set it equal to 0. Now the nice thing about this is when you go to multiply both sides by the x minus 1 and you multiply by 0, it cancels out, right? So it's really just setting the numerator equal to 0. So it's actually not that bad after all. So numerator equal to 0, this is going to also say that x is equal to 3. So x is equal to 3. So we've got 2 points on our graph and the 2 asymptotes. And believe it or not, we've got enough to draw our graph. You might be like, what the heck are you talking about? But I guarantee it. I want you to think about that base graph. That base graph, remember how it hugs the asymptotes, okay? It's those arcs that hug the asymptotes. Now, we have a point here. And this point is part of a graph that's going to hug the asymptotes. So I know that the shape is always going to be that kind of arc that hugs in there. So because I have a point up here, I know the arc is going to go there. It doesn't go down here because there were no points down here. Then we move over to this side of the vertical asymptote. And again, we're looking for an arc. But is the arc going to be up here or down here? Look what we've got. We've got a point there. So we know that our arc is going to fit in like that. Now, I know at first you might be like, oh my gosh, how did she know that that's what it's going to look like? But that's part of understanding what the base graph looks like and knowing that even though this isn't the base graph, it's still going to be very similar in format. Okay? All right, so we've done our first one. Let's do one more, and then we'll possibly take a break and do part 2, okay? So let's see. So let's do that one that hold on. Let's do that one that we just kind of worked on and see what it looked like. Might as well. So we had that 2x minus 3 over the x squared minus 4. Okay. And remember, as a reminder, Our vertical asymptote was this guy, the denominator set equal to 0. But when we simplified this, what did we find about our vertical asymptote? That we actually had 2, right? So there are actually 2 vertical asymptotes. So this graph is going to look a little bit different. So if we draw our graph to start with, we've got plus or minus 2, so there's minus 2, there's plus 2, and I'm going to draw that dashed line. And remember, we're just doing the best we can. It does not need to be perfect. So there is a VA and there is a VA. Okay. Now, our horizontal asymptote, again, we're looking at this part, and the top is smaller than the bottom. So what did that mean? It meant that we have y equals 0 as our horizontal asymptote. I forgot to label my graph here. Now, this one is a little harder to show because the dashed line is right across the x-axis. So it's very important that you label this one so that I can see that you knew where it was. Okay. Asymptotes on the graph. Now it's time for the points. So, y-intercept. So if we plug in 0 in for the x's, we're going to get -3 over -4, or +3/4. And that one is our y-intercept. So if we say that this is 1, then we're going to be right about there. And you've got to be ready to see fractions. Because we're starting with a fraction, it's a very good bet that there will be fractions going on in here, okay? Fractions, not decimals. I want to see things in fraction form, not decimal form. All right, and then our x-intercept. So remember, again, we're taking the whole function and setting it equal to 0, but the bottom is going to cancel. So we actually just have the 2x minus 3 equal to 0, which means x is going to be equal to 3/2. Everybody agree with 3/2? Okay. So 3/2 is 1.5, so that's going to be right about here. Now, one thing I told you was that the asymptote was like a boundary that the graph doesn't touch or cross, and yet right here, if you're hearing that, that's the donkey. She's telling me she wants her evening food. Okay, right here, we're crossing the asymptote. So what the asymptote actually means is it's not going to touch or cross as we go out towards negative and positive infinity. In the middle of the graph, all bets are lost. Okay, all bets are off. You can do whatever you want. Now, I don't have any clue what's going on over there or over here yet because I don't have any points, but I do know what's going on here. And we can look at this because these 2 points have to connect, don't they? Now remember, we're still going to hug that asymptote. So what we need to decide is whether this guy is going to come down and hug the asymptote here, or if he's going to continue up and hug the asymptote up above. And I know that he's going to do this. And the reason why I know is because, is there anywhere where it crossed the x-axis down here? So he cannot come and go over here because he'd have to jump over the x-axis. And then we can say that this one hugs the asymptote there. So I only need those 2 points and then the asymptotes to tell me what's going on. Now, over here and over there, we got to figure something out. So when you don't have enough points, sometimes you're going to have to use a test point, okay? And that's what we're going to do. So we're going to use a point out of this region over here, like -3. I mean, like if you like -10, go for it, whatever you want, okay? So let's let x equal -3, and we're going to stick it in here. R of -3 is going to be 2 times -3 minus 3 over negative 3 squared minus 4. So up top, let's see, we're going to be at negative 6 minus 3 more is negative 9. And on the bottom, we're going to be at 9 minus 4, which is 5. Now, more important than the fraction is just that it's negative, which means that it's, let's say, somewhere right about there. Now, if I know that there's a point in this section, then there's not going to be anything up here. And it's going to be in here, and what's it going to do to those asymptotes? It's going to hug those asymptotes. So with 1 point, I know that the graph is going to look like that, hugs those asymptotes. Okay. Now I'm going to go to the other side, and let's just use, positive 3 just for the heck of it. So we're going to let x equal positive 3. So r of 3 will be 2 times 3 minus 3, all over 3 squared minus 4. So this one is going to be 6 minus 3, so that will be 3. And this one is still going to be 9 minus 4, which is 5. But this one is positive. So, and it's 3/5, so I don't know, it's like there-ish, let's say. But now what do I know? We know that it's going to do this. The arc is going to fit in there because the point is here, not down here, and it's going to hug in with those asymptotes. Okay. So that is what you are looking for. So as you're starting, I want you to try to figure out kind of what's going on without doing too many test points. But as you're starting, if you need to do a test point, like if you really are not trusting me, plug in -1 and see what happens. And it's probably not to scale, but I'm pretty sure it's going to be up here. So you can always plug in more test points to make yourself more sure, but you want to try to think about, what do the asymptotes tell us? What do the intercepts tell us? Okay, so let's cut it here, and then we'll just come right back with part 2 in a minute.